Hello and welcome to this live stream. I would like to just quickly check if everything has started, but I believe because I did a pre-recording using another previous live and I tested everything before starting this one and that one worked perfectly. So I hope this one also runs smoothly. Look to run smoothly. Look to run smoothly. Okay, so in this live, I'm planning on solving um question 7 extension. Question 7 extension, I'm actually moving slow. Okay, so the frame rate is a bit off, slowing my motion down, but I pray it's not as bad. Okay, so in this video, we're going to solve question. I've already done solve all the questions. Okay, this is makeup. I've already solved all the question in the test two. I've done test one already. This test two, I've solved the question in test two. So Um, but I wanted to solve question 7 as afresh. Do question 7 afresh from the beginning and explain it more details because question 7 I do a particular question twice. That whenever I finish test review and I go back and make a video specific for a question. Before I continue, please just check if everything is functioning. But every extension, I'm actually moving slow. Okay, so the frame rate is a bit slowing my motion down, but I pray it's not as bad. Okay, so in this video, we're going to solve the question. I've already done solve all the questions. Okay, the video is as good as I want it to be. Just that, as I said, it's slowing my motion down. I'm seeing that, um, like I'm not moving as fast as I am moving in real life. So I know that the frame rate is a bit low, but I don't really know how to fix it now that I started the live. But maybe it's the internet. Maybe the internet is not strong. But I'll just consider like that since the audio is working because the main problem that I've had in doing this live stream is the audio. The audio keeps going off. Let me put it now. Keeps so, so we're going to solve question 7 again. And before I begin, I just want to do the necessary. I want to say thank you to the math department. I say thank you to Dr. Daniel, the amazing Dr. Mr. Mr. Francis, the amazing office. I want to thank you to everybody. I want to thank you to the school. Also, thank you to finish up the makeup test that they had. After the makeup test, I'm not going to solve the 100 questions that they gave as practice questions. But for today, or for now, for this particular video, all we are going to do is to study everything under the integral of sine to the power of 6x dx. We want to study everything that this integral entails. Now, I want to state out there that in maths, there is no one way to solve a question. There are multiple ways you can handle a question. I believe I've said this multiple times, so there are multiple ways to solve a question. Most of the time, people believe that for them it is maths is like an algorithm. When you want to find your quadratic formula, just do minus b plus minus square root of b square minus 4ac. They don't embrace the beauty of it, the almighty formula that was put in place to get that formula, to get that almighty formula. They don't embrace the completely the square method that was put in place to get that almighty formula. And it begins to make people believe that math is cramming, that to pass math, all you need to do is to cram, 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 cram. People begin to learn multiple formulas and few them inside the exam and maybe they will not forget the formula and will not fail the exam. They forget that in maths you can use multiple other methods. It's not by force for you to learn one method, you can learn multiple methods I've studied. But eventually, when I tried my best to become good, very good in maths, I've stopped doing that method of study before the exam. Instead, I just once it's time for maths exam, I stop reading. I stop reading for the maths. I go inside the exam hall with the ones I already have at the back of my head, and you write the test. So right there in the exam hall, if there's something that I needed and I've not learned it, and maybe it makes me fail that test, I will make sure I learn it after the test. So I try my best to enter to read and read to understand it basically. So integral, there are two ways to solve it. There may be more. There may be more. Just like there may be more. But there are two ways that I've seen so far that I can use to solve this. When I saw the question in the assignment, I normally solve my assignment using multiple methods, and I give to Dr. Abola, and Dr. Abola checks to check it to see if all the methods are correct. And I tried finding a third method to solve this integral, and I didn't have success. All the other methods that I had, they ended up having, they ended up reaching a point where I have to now go back and use the initial first two method, either of the first two methods. So it's just basically we are going in circles. So end of the day, I just found only two methods to solve the question. So in case you have other ways to solve this integral, you can drop that in the comments. But for today, I'll show you my own two methods, and it will actually give you two different results. But I'll show you that those two results that it gives you are actually the same thing. So now let's see how we solve this integral. We have the integral of sine to the power of 6 dx. The first way I want to solve this is using the power reduction formula. Now, the power reduction formula helps you reduce all these integral. You have integral to the power of 6. You can reduce it to the power of 4, reduce it to the power of 2, then reduce to the power of 0. When you reduce the power of 0, you're going to have the integral of dx. And the integral of 1 dx is basically just uh, x. The integral of 1 dx is basically just x. Before I continue, let me just try to refresh this page. Okay, I tried refreshing the page to see if it will make me go back to normal speed, but the frame rate is still low, as I've seen. But I'll just continue anyway, since I said Udo is okay. So the first method is going to be power integration formula. But instead of just showing you the power integration, the power reduction formula, right? Instead of just showing you that one, I'm going to solve it just like the almighty formula. Instead of using the almighty formula, I'm going to solve that quadratic using completing the square method. The almighty formula is just a simpler way of using completing the square method, without all the steps. Let's say with power reduction formula is basically just this one without all these steps. But I'm going to show you the steps. So on your own, you can now find or you can now derive the power reduction formula for yourself. Using whatever I'll show you, you can do it for the n term. That is the integral of sine to the power of n of x dx. So you can use the step that I use to solve this one to now derive the general formula for the integral of sine to the power of n x dx. So the first thing I want to do here is, since we are saying sine to the power of 6x, we can break that sine to the power of 6x to sine to the x times 5 times sine x. So we have, first of all, let this integral equal I. If you say let the integral equal I, and I'll tell you that sine to the power of 6x is equal to sine to the power of 5x times sine x. So we have sine to the power of 6x is equal to sine to the power of 5x times sine x. Good. Then we can now put this our expression into our integral. So we have I is equal to the integral of sine to the power of 5x times sine to the power of sine x dx. So we have sine to the power of 6x equals sine to the power of 5x sine x. So inside the integral, we have sine to the power of 5x times sine to the power of sine x dx. Okay. Now we're now going to apply the um, integration by parts. We're going to integrate both sides individually. So we say let u, I want to say let u1, yes, let 1 equal to sine to the power of 5x I'm going to use u1 because we're going to integrate by parts multiple times. After we finish the first solution, we're going to have sine to the power of 4. So we still need to integrate sine 4x dx. We now need to integrate sine to the power of 2x dx. So I'm going to use u1 since this is the um first completing no first this is name they call this thing. This since is the first integration by part that we're doing. I'm going to use u1 sine is equal to sine power 5x and let the derivative of v1 equal to sine x dx. If you differentiate u1, you're going to get the derivative of u1 is equal to, if you differentiate sine to the power of 5x, remember you bring down the power, then reduce the power by 1. So that's 5 minus 1, which is 4. So you have sine to the power of 4x. Then the inner function is sine x. This is sine x all to the power of 5. So you're not going to differentiate sine x, and that will give you cos x dx. Okay, in case you don't understand how I got this, let me just solve the thing here. So you have u1 is equal to sine to the power of 5x, which is equal to sine x all to the power of 5. Let I equal to sine x. Now the derivative of I is going to equal to cos x dx. If you look at it, if you want to differentiate u1 with respect to x, it's not really direct. So you have the derivative of u1 with respect to x will equal to the derivative of u1 with respect to I times the derivative of I with respect to x. The derivative of u1 with respect to I, let's write that down. You have u1 is equal to sine x to the power of 5 and sine x is equal to I. So u1 is going to equal to I to the power of 5. And if you differentiate u1 with respect to I, you're going to get 5I to the power of 4. And since I is equal to sine x, you're going to have 5 sine x all to the power of 4. So you have 5 times sine x to the power of 4x. Okay. Then the derivative of I with respect to x is equal to cos x. Because if you divide both sides by dx, this dx will cancel from here and to come here. So you have the derivative of I with respect to x is equal to cos x. So you now multiply that in. So you have 5 sine to the power of 4x cos x dx. Okay. Actually, it's just going to be cos x. The dx will actually be here. But since we multiply, if you multiply by dx, that's when the dx now will come here. Multiply by dx. So you have the ui over dx. Then multiply by dx and dx will come here and dx will be on this side. So this is basically how we get this expression here. I hope my audio is still okay. The speed is still slow. It's still the frame rate is still low. But okay, I don't think I can fix that. But if you now, since we have the derivative of v1 is equal to sine x dx, and you now integrate both sides, you're going to get v1 is going to equal to negative cos x. It's equal to negative cos x because if you differentiate negative cos x, you're going to have sine x dx. So now I can put it all this inside your integration by parts formula. You have the integral of u dv is equal to uv minus the integral of v du. I have explained how they got this integration by parts formula before in multiple videos, so you can go and check those videos out to see how we got it. But let me just give a brief explanation. If you have here as the u axis and here as the v axis, then the area of this rectangle here is going to equal to uv. Let's say you have a function that has a graph like this, right? Then the area under here is equal to the integral of v with respect to the u-axis. While the area above is going to equal to the integral of u with respect to the v-axis. So you have uv is going to equal to the integral of u dv plus the integral of v du. Now if you move this to the left hand side, you are going to have the integral of u dv is going to equal to uv minus the integral of v du, and that's how you get the integration by part formula. But in this case, we're using u1, the v1, u1, v1, v1, and the u1. Okay. So we have the integral of u1. u1 is sine to the power of 5x times the v1. The v1 is equal to sine x dx. So we have the integral of sine to the power of 5x times sine x dx, and this is equal to I. So you can just write it down as I is equal to, you have u1 times v1. u1 is equal to sine to the power of 5x, and v1 is equal to times minus cos x. We have minus the integral of v1 du1. v1 is equal to minus cos x, and du1 is equal to 5 times the power of 4x cos x dx. 5 times the power of 4x cos x dx. So we've reached this part here. And now let's simplify. This simplification now is just algebra. So it's nothing much. We have I is going to equal to sin to the power of 5x times minus cos x will give you minus sin to the power of 5x cos x. Okay? Now if you look at this here, you have minus here, you have minus here. So that will turn to plus. Because minus times minus is plus. If you look at it, there's 5 here. 5 is a constant. So you can bring out the constant. You have plus 5. Then you can write down the rest. The integral of sin to the power of 4x cos square x dx. Now don't be confused. How did I get sin to the power of 4x cos square x? If you look closely, you have sin to the power of 4x already here. Then you have cos x times dx. That's how you get cos square x dx. I believe that is understood. Let's proceed. Let me bring down the camera so you can see the down part. Okay. Now finally, we are going to now express cos square x in terms of sin x. Cos square x is going to equal to 1 minus sin square x. So I'm going to use this identity, cos square x is equal to 1 minus sin square x, to simplify this expression here. So I'm going to clean the board at this point, because I don't think we need this part anymore. Please, you can be jotting down in case you want to make reference to this later on. Okay. So if you put this back in, you are going to have I is equal to minus sin to the power of 5x cos x plus 5 times the integral of sin to the power of 4x times cos square x is equal to 1 minus sin square x. So instead of cos square x, we are going to put 1 minus sin square x times 1 minus sin square x dx. Good. Now, if you want to simplify this now, remember you have sin to the power of 4x times 1 minus sin square x. If you open the bracket, you're going to have sin to the power of 4x minus sin to the power of 6x. You have sin to the power of 4x times 1, which is sin to the power of 4x. Sin to the power of 4x times minus sin square x. That will give you minus sin 4 plus 2, that is 6. So minus sin to the power of 6x. So instead of sin to the power of 4x times 1 minus sin square x, I'm going to just write sin to the power of 4x minus sin to the power of 6x dx. Now we don't need any of this anymore. Okay? In case you have any question, you can ask though. Okay. So now, if you have the integral of a difference, or if you have the integral of a sum, it can change to the sum of integrals. Using that same knowledge, if you have the integral of a difference, it can change to the difference of that integral. So you have I would equal to minus sin to the power of 5x cos x plus 5 times the integral of sin to the power of 4x minus 5 times the integral of sin to the power of 6x dx and dx. Now, how do we do this? We have 5 times the integral of times the power of 4x dx. There's already a minus here, so you have minus times 5 times the integral of sin to the power of 6x dx. That's how you get that over here. So if you want to simplify that further, you now have to pull back that initial value for I. Remember, I is equal to the integral of sin to the power of 6x dx. So you have the integral of sin to the power of 6x dx is equal to minus sin to the power of 5x cos x plus 5 times sin to the power of 4x dx minus 5 times the integral of sin to the power of 6x dx. If you look at it, you have the integral of sin to the power of 6x dx and you have the integral of sin to the power of 6x dx. You can move this sin to the power of 6x dx over to the left hand side so they will be together. So it's just like collecting like things. So if you move this over to the left hand side, remember the negative will turn to positive. So this will be 1 plus 5 times the integral of sin to the power of 6x dx. And 1 plus 5 is what? 1 plus 5 is basically just 6. So that is 6 times the integral of sin to the power of 6x dx. And this will equal to minus sin to the power of 5x cos x plus 5 times the integral of sin to the power of 4x dx. What did you notice? We have the integral of sin to the power of 6x is equal to a reduction sin to the power of 4x. It was reduced. It's no longer as high as 6, it's now 4. So if you do this again, if you go through this process again, it's now reduced to 2. If you go through this process again, it's now reduced to 0. And when you have the integral of sin to the power of 0x dx, this will equal to the integral of 1 dx, which is equal to x. So you can try this out by yourself. You can leave the live now and go and try it by yourself if you wish, and then come back to check your solution. But now remember, we're not looking for the integral of sin to the power of 6x. We're not looking for 6 times the integral of sin to the power of 6x dx. We're only looking for the integral of sin to the power of 6x dx. Now, what do? We divide all through by 6. Since we're looking for x, we're not looking for 6x. We divide by 6, so we get only x. So let's divide by 6 here. If you divide by 6, you are going to have the integral of sin to the power of 6x dx. And sin to the power of 6x dx is basically just I. So I is going to equal to minus 1 over 6 sin to the power of 5x cos x plus 5 over 6 times the integral of sin to the power of 4x dx. Now the reason why is minus 1 over 6 because you are dividing by 6, so you have minus 1 divided by 6, and you have 5 over 6 here because there's only 5 here, so that's 5 divided by 6. I think that is simple, that is easy to understand. So now that I've reached this part, I'm going to write what we just got it now at the top. So all this is equal to minus 1 over 6 sin to the power of 5x cos x plus 5 over 6 times the integral of sin to the power of 4x dx. Okay. Now, the next task is to find what the integral of sin to the power of 4x dx is. And to do that, I would like to start with, let the integral of sin to the power of 4x dx equal to j. If we let the integral of sin to the power of 4x dx equal to j, then we can also say that this is equal to the integral of sin to the power of 3x times sin x dx. Remember, this was the first step we did when we were doing this. We're still within here. We're not doing that detail, so I can clean that up. We're still within here. We have sin to the power of 6x is equal to sin to the power of 5x times sin x. That's what we're going to get. Sin to the power of 4x is going to equal to sin to the power of 3x times sin x. To the two people that are watching, you can tell me in case the audio is working. I know that the visual, is slow. I believe it is not as, like it's not smooth. My motion is not smooth. Don't mind that. I don't know why the camera is having a low frame rate this time. But you can tell me if the audio is, in case the audio is crap, because I'm trying my best to make sure the audio is clear. Because I feel what you need now is more of audio, so you can understand the explanation than visual. So, but I'm trying my best to fix the visual, but then the visual is not fixing. But let me just continue from my solution. Let's continue the solution. Okay. So now let's find J. J is equal to the integral of sin power of 3x times sin x dx. Remember, we're now going to say let u1 or u2 this time, let u2 equal to sin to the power of 3x. I'm already sweating. Okay, if we say let u2 equal to sin to the power of 3x, oh my god. Okay, it's not a problem. I thought the ink busted. It's not dripping on my hand. I thought the ink busted. Oh, it's still okay. But I don't even make extra ink. So let's u2 equal to sin to the power of 3x. Okay, then we're going to say let the v2 equal to sin x dx. There's no need for you to struggle with which one to use. You have sin to the power of 3x here. It's obviously more complex than sin x. Let us say you have x sin to the power of 3x. Then you are going to pick this one to be your u2. But by the time you differentiate x, it's going to reduce. It's going to reduce for you. But by the time you differentiate sin to the power of 3x, it's going to increase to this. So it's better to differentiate x than to differentiate this one. So let's say you're going to integrate this part and differentiate this one. But in this case, you are going to integrate the smaller one, that is sin x dx, and differentiate that bigger one. You have u2 is going to equal sin 4x, and the v2 is going to equal to sin x dx. I don't know why this thing is pushing out things like this. Okay, we continue our solution. Remember, you take the first, continue the way you did last time. Let's find our u2. The derivative of u2 is going to equal to 3 times the sine square x times cos x dx. I don't really think you need me to explain this again, but in case you still do not get this thing, what do you call that thing again? Chain rule. In case you don't understand the chain rule, let me explain it again. One last time, I'm not going to explain this again. But you have if you have u2 is equal to sine to the power of 3x, and you want to find derivative of u2 with respect to x, right? But u2 is not directly linked to x. Instead, it is equal to sine x to the power of 3. So what you are going to do is let I, or in this case, let's say something else. Let maybe let y equal to sine x. Therefore, u2 is equal to y to the power of 3. The derivative of u2 with respect to y is going to equal to 3y squared, which is equal to 3 times sine x squared, which is equal to 3 du2 over dy over d4 times dy over dx. Now, what's your dy over dx? Since y is equal to sine x, your dy over dx is equal to cos x dx. Okay, it's giving me warning that my connection is unstable, that they'll try to reconnect. Okay, I think it's back. I think I pray the audio is working. I pray it's working. But in case that, yeah, you can tell me confirm if it's working. But if it's not working, please tell me. But anyways, let me continue from where I stopped. The YouTube was telling me that my connection was bad, so I have to reconnect. Okay, it's still lagging, still lagging. But I'll just continue. I'll look at the derivative of u2 respect to x. And we say this is equal to derivative of u2 respect to y times derivative of y respect to x. Okay. Derivative of u2 respect to y is already equal to 3 times square x, as I've seen here. And derivative of y respect to x, let's find out now. Y is equal to sin x. This implies that the derivative of y with respect to x is equal to cos x. So we have u2 over dx is going to 3 times square x times cos x. And that's what we have here. 3 times square x times cos x. Then that is equal to du2 over dx. Then if you multiply both sides by dx, we now have du2 is equal to 3 times sin square x times cos x times dx. We want the du2 to be alone, so we put dx here. Let me we go to this so we can clear this off. And now let's go to our dv2 over the dv2 is equal. Let's go to our dv2. Dv2 is equal to sin x dx. And if you want to find v2, you have to integrate both sides. And if you integrate both sides, you are going to have v2 is equal to, if you integrate sin x dx, you're going to have minus cos x. This is because if you differentiate minus cos x, you're going to have sin x dx. So now, remember the formula, the integral of uv, sorry, udv is equal to uv minus the integral of v du. In this case, we are doing the second one, so that is the integral of u2 times dv2 is equal to u2 times v2 minus v2 du2. This implies that the integral of u2 sin cube x times dv2 sin x dx. Remember that all this here is same thing as g, because this will give you the integral of sin 4x, and that is g. You can also say that this implies that j is equal to u2 times v2. u2 is equal to sin x times v2. v2 is equal to minus cos x minus the integral du2. du2 is equal to, no, yes, du2. Okay, du2 is equal to 3 sin square x cos x dx. So I'm going to write down here 3 sin square x cos x dx. Good. So now let's simplify. This implies that j is equal to minus sin cube x cos x minus sin cube x cos x minus times minus, that is plus. You have 3. 3 is a constant, so you can bring out 3 times 3 times the integral of sin square x cos square x dx. How do you get sin square x cos square x dx? You can see it from here. You have sin square x already. You have cos x times cos x, we give cos square x. Then you have dx. You put it here. This further implies that j, or you can stop here. You can stop here. Now let me clean from the top. Let me clean from the top. And let's simplify. Remember what I used it to simplify? Minus sin square x. We're using this identity. Now I put the identity in there, but j is equal to, or square x times 1 minus sin square x dx. It is 1 minus sin square x because you have cos square x here. So you're going to put that cos square x. Cos square x equals 1 minus sin square x. Good. Okay, 2 people viewing. Hello. Okay. If we simplify sin square x times 1 minus sin square x, you are going to get sin square x minus sin to the power of 4x. And that's what we're going to use to simplify this here. So you have sin square x times 1 minus sin square x is equal to sin square x minus sin to the power of 4x. So instead of this, we're going to write minus sin to the power of 4x dx. So now I can clean the whole thing up. Good. The same thing happens that we did last time. That's what we're going to do again. So this is going to be equal to plus 3 times the integral of sin square x dx minus 3 times the integral of sin to the power of 4x dx. The integral of a difference is equal to the difference of each integral. Okay. You can write down the rest of the things again. Now don't forget j is equal to something. J is equal to the integral of sin to the power of 4x dx. Good. Now if you move this to the left hand side, you are going to get 4 times the integral of sin to the power of 4x dx is equal to minus sin to the power of 3x cos x plus 3 times the integral of sin square x dx. Don't forget we're looking for the integral of sin to the power of 4x dx and not 4 times of that. So you're going to divide by 4. If you divide by 4, you're going to get j is equal to minus 1 over 4 sin to the power of 3x plus 3 over 4 times the integral of sin square x dx. Now, this is what we're going to substitute for j. So instead of j is equal to the integral of sin 3x times sin square x dx, we're going to write j is equal to negative 1 over 4 sin 3x cos x plus 3 over 4 times the integral of sin square x dx. Now, how do you find the integral of sin square x dx? What's it this time? Okay, don't need to send me message this time. It's my own system. So I can continue. Let me put this page. Yeah, so I can stay connected. Okay. So now let's find the integral of sin square x dx. Let's call that k. Let the integral of sin square x dx equal to k. Therefore, that is equal to the integral of sin x times sin x dx. The same thing happens here. Let u3 equal to sin x, and let the v3 equal to sin x dx. If you differentiate u3, you're going to have the derivative of u3 is equal to cos x dx. And if you integrate the v3, you're going to have v3 is equal to negative cos x dx. Good. Now let's put our formula. We have the integral of u dv is equal to uv. So that will be the integral of u3 dv3 is equal to u3 times v3 minus the integral of v3 du3 dx. And this is equal to u3 times v3. So this is sin x times v3, that is negative cos x, minus the integral of v3 times du3. v3 is equal to negative cos x dx. No, that's not totally correct. Equal to negative cos x. Equal to negative x. And the v3 and the u3 is equal to cos x dx. Good. So this implies that k, remember that k is equal to the integral of sin square x dx from here. So k is equal to negative sin x cos x. We have k is equal to negative sin x cos x. Minus and minus, that's plus the integral of cos square x dx. So you have k is equal to the integral of sin x cos x plus the integral of cos square x dx. That's the same integral of sin x dx cos x. I meant we have k is equal to negative sin x cos x, not the integral of sin x cos x. Anyways, we'll continue from the top here. K is equal to the integral of sin square x, and that is equal to negative sin x cos x plus the integral of 1 minus sine square x dx. If we expand this, we're going to get negative sine x cos x plus the integral of 1 dx minus the integral of sine square x dx. This is equal to the integral of sine square x dx. If you move this to the left hand side, you're going to get 2 times the integral of sine square x dx is equal to negative sine x cos x plus, you can see now you don't need for the power reduction formula again, because here we have the integral of 1 dx, and the integral of 1 dx is simply just x, 2 plus x. So let me clean more. Good. Now we're looking for sine square x dx and not 2 times sine square x dx. So we're going to divide that by 2. So the integral of sine square x dx, which is equal to k, is equal to negative 1 over 2 sine x cos x plus x over 2. So this goes by one side. Negative 1 over 2 sine x cos x plus x over 2. So now let me stand up and write it up. Instead of k is equal to all this, we'll just say k is equal to negative 1 over 2 sine x cos x plus x over 2. Now, when you are done, we now have to put everything together. Remember, we're looking for I, and I is in terms of j, and j is also in terms of k. So we need to put everything together. Let's find j first. Let's simplify j. J is equal to negative 1 over 4 sine to the power of 3x cos x plus 3 over 4 times the integral of sine square x dx. This sine square x dx is equal to k, and k is equal to this. So instead of the integral of sine square x dx, we are going to just write 3 over 4 times negative 1 over 2 sine x cos x plus x over 2. If you expand the bracket, you're going to get negative 1 over 4 sine to the power of 3x. I hope you are clear from this side. Yeah, I think that's clear. So you have negative 1 over 4 times sine cube x cos x plus, no, not plus, negative, minus 3 over 8 sine x cos x. It is negative because here you have 3 over 4 times negative 1 over 2 sine x cos x. That will equal to negative 3 over 8 sine x cos x. 3 over 4 times 3 over 2, that will be plus 3. That will be plus 3 over 8x. So we have j is equal to negative 1 over 4 sine cube x cos x plus, or rather, minus 3 over 8 sine x cos x plus 3 over 8x. So this is our simplification of j. We've simplified j already, so we don't need any of this anymore. We don't also need k again, but we're going to simplify j. K was needed to simplify j, our simplified j, so there's no need for k again. Now, let's simplify I. I is our final solution. That is the integral of sin to the power of 6x dx. So once you simplify I, we're done with this part. Let's simplify I. I is equal to negative 1 over 6 sine to the power of 5x cos x plus 5 over 6j. Remember, j is equal to sine to the power of 4x dx. So that's 5 over 6j. But that j, we simplified it to be negative 1 over 4 sine to the power of 3x cos x negative 3 over 8 sine x cos x plus 3 over 8x. Now, if you expand this, we are going to get negative 1 over 6 sine to the power of 5x cos x plus 5 over 6 times negative, no, minus 5 over 6 times negative 1 over 4 is negative 5 over 24 minus 5 over 24 sine to the power of 3x cos x. 5 over 6 times 3 over 8. We have 5 over 6 times 3 over 8. 3 here 1, 3 here 2. That equals 5 over 16. So we have 5 over 16. Okay? So that would be negative 5 over 16 sine x cos x. 5 over 6 times 3 over 8. That would be positive 5 over 16 x. So finally, we don't need j anymore. So simplify I. So finally, we have I, which is equal to the integral of sine to the power of x, or sine to the power of 6x dx, is equal to negative 1 over 6 sine to the power of 5x cos x minus 5 over 24 sine to the power of 3x cos x minus 5 over 16 sine x cos x plus 5 over 16x. I feel like it would be better to write it down in full. So let me write it again. This is the top here. Okay. Let me write it again. We have I is equal to the integral of sine to the power of 6x dx, which is equal to negative 1 which is equal to negative 1 over 6. Negative 1 over 6 sine to the power of 5x cos x. Negative 5 over 24 sine to the power of 3x cos x. Negative 5 over 16 sine x cos x plus 5 over 16. Good. So this is our final answer. Now I'm going to show you another method. In case this method is complex for you and you want to find a simpler solution, I'm going to show you a second method that you can use to solve this question. The second method may be easier for you, it may be harder, depending on who you are. But let me just check if this thing is clear. Yeah, I believe it is clear enough. I believe it's clear enough. Let me bring this audio here so you can be able to hear me better. I believe you can hear me better because of this, the audio that I'm using to make this video. Okay. Yeah. So let's now use the second method. This is the first method. This process is actually the process to get the reduction formula in calculus. So you can use this method to get the integral of sine to the power of nx dx. You can use this to get it. I'm not going to use this video, but in case you want me to do this, then you can tell me in the comments, and I'm going to create a video separately for this particular expression to get the reduction formula for this, and also get it for the integral of cos to the power of nx dx, the both of them. I believe there's also going to be a reduction formula for tan, but I'll get for this too. So you can tell me in the comments and I'll do that. But with this process, this process I've just showed you now, you can reduce any of them as much as you want. You have this step by step. You have this, but that one will give you the formula. It's like using almighty formula. Instead of solving step by step instead of completing the square method for almighty formula, for this thing for quadratic, you can just use almighty formula and get your final answer. So that's the way the reduction formula works. Instead of reducing them one by one, following the process, you can just use the reduction formula and to go straight to the point for you. But me, I'm not giving you the one that okay, it will still be recording. I'm not giving you the one that will not help you. Let me this one will be better because that reduction formula is quite complex. It's quite complex to learn that reduction formula from scratch right now. Because the exam is on Tuesday. So I give you that reduction formula now, you may not be able to cram it. So it's better I show you this process so you can learn this process, and you can solve anyone, anytime, anywhere. So that's how I'm giving this one. But now I'm going to give you a second method, which some people may find easier. Let's find that second method. Let's see that second method now. That method, that second method relies on the fact. Let me show you. Okay. That method relies on the fact that you can change sin square x to a trigonometric function that only has a power of 1. Now, how do you do that? Remember your trig formula for cos x. Cos 2x is equal to cos square x minus sin square x. So this is equal to cos square x, or this is equal to 1 minus sin square x minus sin square x. Because cos square x is equal to 1 minus sin square x. Equal to 1 minus sin square x minus sin square x. Is equal to 1 minus sin square x minus sin square x, which is equal to 1 minus 2 sin square x. Right? So you can now apply some algebra here. If you move this minus 2 sin square x to the left hand side, you're going to get 2 sin square x is equal to 1 minus cos 2x. We divide both sides by 2, you're going to get sin square x is equal to 1 minus cos 2x divided by 2. So you can see that you have reduced sin the power of 2. You have reduced it to a trigonometric function that has the power of 1. And whenever you have a trigonometric function with the power of 1, you can easily integrate it. You can easily integrate it. So that is why you need this formula for this second method. Now let's use it. Or how do we use it? Let me remove one handkerchief. So this is our final solution using the first method. Let's now use our second method. We have sin to the power of 6x. This is equal to sin square x to the power of 3. Because remember, when you have a to the power of m or to the power of n, this is equal to a to the power of m times n. So if you have sin to the power of sin square x to the power or to the power of 3 is equal to sin to the power of 2 times 3 x. And 2 times 3 is going to be equal to sin to the power of 6x. So now the camera, the microphone goes my one. I hope it's not giving that effect. But okay, let me just continue like this because I feel like it's better for you to get quality audio since the visual is not that good. Okay, sin square is equal to something. Sin square is equal to 1 minus cos 2x over 2. No, was it 1 minus? I think it was 1 plus. Okay, let me just solve it again. We have cos 2x is equal to cos square x minus sin x. This is equal to 1 minus 2 of this. If you move this here, I'm going to have 2 sin square x is equal to 1 minus cos 2x. Then divide by 2. Okay, that will be 1 minus here. Okay, so that will be 1 minus cos 2x divided by 2. All to the power of 3. Now, if you apply your polynomial expansion, you can now remove these 2 here to turn it to 1 over 2 times 1 minus cos 2x all to the power of 3, which is equal to 1 over 2 to the power of 3 times 1 minus cos 2x to the power of 3. I believe you understand to this point. 1 over 2 to the power of 3 is equal to 1 over 8. And 1 minus cos 2x to the power of 3 is equal to 1 minus 3 cos. No. 1 minus 3 cos 2x minus no plus 3 cos square 2x minus cos cube 2x. Now, how do I get these values? for Pascal triangle, I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So this will be 1 to the power of 3 times 1 plus 3 times 1 squared times negative cos 2x. That's what gave us negative 3 times cos 2x. Then we have 3 times 1 to the power of 1 times negative cos x all squared. That's what gives us 3 times cos squared 2x, because negative will cancel out since we're squaring it. Then plus 1 times 1 to the power of 0 times negative cos 2x to the power of 3. 1 times 1 to the power of 0 is just 1 times negative cos to the power of 3 2x. Now this is negative because of negative times negative times negative. Give you negative times negative, that would be positive times negative, and positive times negative is negative. That's why it gives you negative here. Okay. If we are raising by an even power, it will be positive. If we are raising by an odd power, it's negative. So we have negative cos to the power of 3 2x. So sin to the power of 6 simplifies to 1 over 8 times 1 minus 3 cos 2x plus 3 cos squared 2x minus 3 cos minus cos to the power of 3 2x. I'll write down our simplification up here. Which is equal to 1 over 8 times 1 minus 3 cos 2x plus 3 cos squared 2x minus cos to the power of 3 2x. Good. Now, we can simplify this further, because remember, if you look at it, right, if we're integrating this, what we're going to integrate on the right hand side, we still have square here. It will also still have cube. We want to make sure that everything is in power of ones, not power of twos and threes, or powers of ones and powers of zeros. Because power of 0 is just 1, so powers of 1 or power of or just a number. Good. So how do we do that? If you look at, let me sit down since there's no need standing again. If you look at cos squared 2x, that's the first one that is there. So you have cos squared 2x. Now, first of all, how do you reduce cos square x? How do you reduce cos square x? Try to be, I'm writing small, but it is still visible. How do you reduce cos square x or cos square theta? Let's say cos square theta. How do you reduce cos square theta to change it to a power, something that has only power of 1? Now, the same way you changed sin square x to have only power of 1. That's the same way you change for cos square x, for cos square theta. So you have cos 2 theta is equal to cos square theta minus sin square theta. This is equal to cos square theta minus 1 minus sin square theta. If you expand this negative, you're going to have cos square theta minus 1 plus cos square theta. So this will be equal to 2 cos square theta minus 1. Now move this minus 1 here, you're going to have cos 2 theta plus 1 is equal to 2 cos square theta. Divide both sides by 2, you're going to have cos square theta is equal to cos 2 theta plus 1 over 2. So instead of cos square theta, instead of theta, let's change theta to 2x. So theta here, you put 2x. That means theta here, you also put 2x. So that will be 2 times 2x. And 2 times 2x is what? 2 times 2x is 4x. Remember, you had cos 2 theta. And since theta is equal to 2x, you have 2 times 2x, which is equal to what? 4x. Not 4x, so I say 4x. So you have cos square 2x is going to equal to cos the power, so not the power, we have cos 4x plus 1 divided by 2. So cos square 2x changes to cos 4x plus 1 divided by 2. So good, we have reduced cos square 2x to something that only has powers of 1 and 0. So we can clean this off. So now how do we reduce cos cube 2x. Cos cube 2x can be reduced because this is equal to cos squared 2x times cos 2x. Right? Right. And remember, squared 2x we just say is equal to cos 4x plus 1 over 2. So that'll be cos 4x plus 1 divided by 2 times cos 2x. If you open the bracket, you are going to have 1 over 2 times cos 2x times cos 4x plus cos 2x. I believe you have seen how I got this. I got this because you first of all have 1 over 2, you bring it out. Then you have cos 4x times cos 2x, you get cos 2x times cos 4x, plus you have 1 times 2x, that will be plus cos 2x on its own. So this now satisfied, but now if you look at it now, we have products. Cos 2x times cos 4x. We really don't want products like that. So we're going to merge those two things together. We're going to merge this cos 2x and cos 4x together. Now, how do we do that? Let me show you this formula. If you have cos A plus B, this is going to equal to cos A cos B minus sin A sin B. If you have cos A minus B, this is going to equal to cos A cos B plus sin A sin B. Good. Now let's add the two of them together. If you add them together, you're going to have cos A plus B plus cos A minus B is equal to 2 times cos A cos B minus sin A B minus sin A times sin B plus sin A times sin B will equal to 0. So you don't need to write down anything. So now if you divide both sides by 2, you're going to have cos A cos B is equal to half of cos A plus B plus cos A minus B. Good. Now let's do some substitution. Let A equal to 2x and let B equal to 4x. If you put that here, you are going to have A plus B will be 2x plus 4x. And A here, A minus B will be 2x minus 4x. Good. 2x plus 4x is 6x. And 2x minus 4x is minus 2x. But since cos is an even function, that means even when you're finding the function to the left and to the right, it's the same value. So cos x is equal to cos minus x. So cos minus 2x is also the same as cos 2x. So we simplify that cos 2x times cos 4x is equal to half times cos 6x plus cos 2x. So we're going to simplify that. That is equal to this part. So I'm going to just clean part of this here. Okay. And we have cos to the power of 3 2x is equal to half cos 2x cos 4x plus half cos 2x. So we have half cos 2x cos 4x plus half cos 2x. Now let's replace what we have simplified here. That means this is equal to half times of half. Half times half is what? 1 over 4. That will be equal to 1 over 4 times cos 6x plus cos 2x plus half cos cos 6x plus cos 2x plus half cos. Okay, the internet got cut off, but now we are back and rolling. Yeah, so where we stopped was here. I'll see that cos cube 2x is going to equal to 1 over 4 times cos 6x plus cos 2x plus half cos 2x. So we are going to use this our, the goal that we're trying to do was to change all the powers of twos, threes, and powers that are not equal to 1 or 0. We're trying to change them to powers that were equal to 1. Oh yes, yes, yes. It was the internet connection that was slow, because now the feedback is faster now. So I believe the recording will have more quality than before. I don't know, it's back slow. Okay, it's back slow now. But it actually feels better than before. But you people should be the ones tell me if it got better or not. But okay, our main goal was to change this power of 2 to a power to trigonometric functions that do not have power, and change this power of 3 to trigonometric functions that do not have power. Okay, so now this, okay, we actually needed that information, but see, it's already here already. So this cosine to power 6x is going to equal to 1 over 8 times 1 minus 3 cos 2x plus 3 times cos squared 2x was equal to cos 4x plus 1 all divided by 2 minus cos cubed 2x is equal to 1 over 4 times cos 6x plus cos 2x minus 1 over 2. No, that was not minus. Plus 1 over 2. No, wait. This is equal to minus here. So the minus is multiplying all through. So this is supposed to be minus. Yeah, that's minus. The minus here, minus cos cube 2x, will multiply all through. So that will be minus this minus this. So minus 1 over 4 cos 6x plus cos 2x minus 1 over 2 cos 2x. Close your bracket. So now we don't need any of this information anymore. We are now going to just substitute back. Expand, sorry, like simplify. I'm just going to simplify now. So now let's simplify. This now will equal to 1 over 8 times 1 minus 3 cos 2x plus 3 over 2 cos 4x plus 3 over 2. So what we have here is half cos 4x times 3, that is 3 over 2 cos 4x. And we have half times 3, that is 3 over 2. Minus 1 over 4 cos 6x minus 1 over 4 cos 2x minus 1 over 2 cos 2x. Bracket close. We can simplify further. This is equal to 1 over 8 times 1 minus 3 cos 2x. Where is the other cos 2x? There's a half 1 over 4 cos 2x here and 1 over 2 cos 2x. So let's just simplify that. That will be minus 3 minus 1 over 4 minus 1 over 2. Is that all? Minus 3 minus 1 over 4 cos 2x and minus 1 over 2 cos 2x. So bring them all under the same denominator. Divide by 4 times 4, that's 12. And divide by 4, that's multiply by 2, that's 2. So that is minus 12 minus 1, that is minus 13 minus 2, that is equal to minus 15 over 4. So this will be minus 15 over 4 cos 2x. Plus 3 over 2 cos 4x minus 1 over 4 cos 6x. Okay, let's proceed. We're going to proceed by, we can either proceed by expanding this, that is taking 1 over 8 and multiplying by all of them. But I will just keep that for now. I will leave that 1 over 8 outside because it's better for it to be outside. Okay. Now I'm going to write this up here. I'm going to write all we've simplified. I'll just put everything up here. Okay, this will have actually have plus c here. That is integral constant. I forgot that before. So we have 1 over 8 times 1 minus 15 over 4 cos 2x plus 3 over 2 cos 4x minus 1 over 4 cos 6x. Good. So we don't need any of this information again, but I've used all of them. Wait, oh, hope I was not, I hope I was not covering the board too much. But okay. We don't need any of this anymore. Actually, the graph is actually a little bit faster than before, which is actually a good thing. But let me just make sure that this microphone is working. Okay, test. Okay, there's no way I'm going to test it. Now let me go set. Okay, let me I can disconnect this system sound. England won Argentina. I think they drew their match, so they have proceeded to the next. Yeah. Wait, Argentina they drew their match. So how did they pick the person that will win? They won. They won in the actual match or in the penalty or something. They won. I think it was extra time. Extra time. Messi did score again. No. Yeah. And this is they cannot say that Messi cheated. Okay, my setting is slowing the system down. So I don't think I'll check. I will not check from here. Let me check from my tablet instead. But okay, our main goal was to change this power of 2 to a power of 2 until 13 is working. So I'll continue. I've checked from my recording. I went to YouTube to check the recording. I said it was working. So I'll just continue from where we are. Okay, so now we're finding the integral of this with respect to x. And we've already shown that sin to the power of 6x is equal to 1 over 8 times 1 minus 15 over 4 cos 2x plus 3 over 2 cos 4x minus 1 over 4 cos 6x. So the integral of sin to the power of 6x is equal to the integral of all this here. But since 1 over 8 is a constant, I'm just going to bring 1 over 8 to the front. So that 1 over 8. 1 over 8 times 1 minus 15 over 4 cos 2x plus 3 over 2 cos 4x minus 1 over 4 cos 6x dx. Good. Now this is going to equal to 1 over 8 times integral of 1 dx minus 1 over 8 times 15 over 4 times the integral of cos 2x dx plus 1 over 8 times 3 over 2 times the integral of cos 4x dx minus 1 over 8 times 1 over 4 times the integral of cos 6x dx. Now, how do we get all this? Remember, the sum of the integral of a sum is equal to the sum of the individual integrals. So since we have the integral of this function, you can break it down as 1 over 8. 1 over 8 multiply everything. So you have 1 over 8 times the integral of the first term dx. That's 1 over 8 times the integral of 1 dx. Then we have 1 over 8 times the integral of negative 15 over 4 cos 2x. But since negative 15 over 4 is a constant, you can bring it out. You have negative 1 over 8 times 15 over 4 times the integral of cos 2x dx plus 1 over 8 times 3 over 2 cos 4x. The same logic applies. Minus 1 over 8 times 1 over 4 the times the integral of cos 6x dx. Good. Now I'm just going to integrate one of them, and I will show you a shorter method to find the integrals. So now whenever you want to find the integral of, I'm just going to show a general case. Whenever you want to find the integral of cos ax dx, you are going to say let u equal to ax. The derivative of u is going to equal to a dx. This implies that the change in x is equal to du over a. Good. So now this is going to equal to the integral of cos u du over a, which is equal to negative sign, no, not negative sign, to equal to sine u divided by a. The reason why is equal to sine u divided by a because of the integral of cos u du is equal to sine u. But don't forget we are dividing by a, so we're going to divide by a here. So that means whenever you have cos 2x, your final answer will be sine 2x divided by 2. Whenever you have sine 3x, your final answer will be sine 3x divided by 3. Whenever you have sine f of x, oh no, let me not say f of x, let's say f of c x, your final answer will be sine f of c x divided by the f prime of, divided by f of c. That's whenever you have a constant here, it will be f of x. Okay, let us say whenever you have cos f of x, just like this, whenever you have cos f of x, your final answer will be sine f of x divided by the derivative f prime of x. This is basically what it is. So whenever you have cos f of x, is going to equal to sine f of x divided by its derivative. You may see this from, you can also see something like this from your differentiation. Whenever you are differentiating, you differentiate the outer function, that is the dy with respect to u, then you now multiply by your derivative with u. So you have dy du divided dx. This will equals us dy over dx, your chain rule. So it's the same thing, basically the same thing that applies here, but instead of multiplying, you are going to divide. In this case, instead of multiplying, after you integrate, you are going to divide. So that's how you get all these ones. So I'm not going to treat each of them as individual cases. I'll just go straight forward and show you people the answer. So this would equal to 1 over 8 times the integral of dx. The integral of dx is equal to x. So 1 over 8 times the integral of dx would be 1 over 8x. Okay. Negative 1 over 8 times 15 over 4 times the integral of cos 2x. This should be negative 1 over 8 times 15 over 4 times sine 2x divided by 2. Let me check. Trigonometric functions that do not have power. I'll change this power of 3 to trigonometric functions that have power. Okay, so now this, we actually needed that information, but see already. So this cosine power 6x is going to equal to 1 over 8 times 1 minus 3 cos 2x plus 3 times cos square 2x was equal to cos 4x plus 1 all divided by 2. Minus cos cube 2x equal to see where 1 over 4 times cos 6x plus cos 2x minus 1 over 2. No, that's not minus. Plus 1 over 2. No, wait. This is equal to minus here. So the minus multiplying all through. So this is equal to minus here. Okay. What we had here was the minus 1 over 8 cos cube 2x times 1 minus 3 this minus this cos 2x. So minus 1 over 4 cos 6x plus 3 minus 1 over 2 times cos 4x plus 1 divided by 2. Minus 1 over 4 times cos. Oh, we don't need all these ones. Not, well, this first thing that is giving me problem now. So if you look at it now, this will be 1 over 8. This will be 1 over 8 times 1. The other time that we'll see this constant term is here. That's 3 over 2 plus 3 over 2. So I'm wondering where I made a mistake and I'm only getting 1 here. It's supposed to be 1 plus 3 over 2. There's supposed to be 3 over 2 here. So I think I omitted that from when I was expanding. So just get correction now. There's okay, Tommy Sin, how far? Tommy Sin, my guy. Well done. Thank you for joining. Okay, so this will be equal to 1/8 times 2/2 plus 3/2. That's basically just 5/2. So that'll be 5/2. Yeah, so this is actually going to be the correct one. I omitted the 3/2 from this part because I can remember that we got that 3/2. So we got at this point, we got the 3/2 cos 4x, which is here. But then I forgot to add the 3 plus 3/2 without any other trigonometric function. I forgot to add 3/2. That will give you 5/2 here. So you have 5/2 that will be here. So yeah, now we are on track. The reason why I spotted that mistake from is because as I'm seeing here, we have 1/8x, but from here we have 5/16x. From here we have 5/16x. So that's how I spotted the mistake. So this now is not 1/8. This is 1/8 times 5/2x. Yes. Minus 1/8 times 15/4 times sin 2x/2. Okay. I'm going to just write this down a little bit lower so it will not clash with what I've written down here already. So this is going to equal to 1/8 times 5/2x minus 1/8 times 15/4 times sin 2x/2 plus 1/8 times 3/2 times sin 4x/4 minus 1/8 times 1/8 times sin 6x/6. So you have seen sin 2x/2, sin 4x/4, sin 6x/6. Good. So I'm going to expand. This is going to equal to 5/16x. Okay. 8 times 4 is 16 times 2, that's 32. So that will be minus 15/32 times sin 2x plus 3 divided by 8 times 2, that's 3 divided by 16. 16 times 4, that is 32, 64. That's 64. So I have 5, no, not 5, 15. 5 times 3 is 15. So we have 15 divided by 64. Okay, sin 4x minus 8 times 8 is 64 times 6. I can't do that in my head, but we have 64 times 6. That's 4, 2, 36, 37, 38. No, we have negative 1/8 times 1/4. So this was 1/4 here. Understand? So try your best not to make all these kind of small mistakes that I'm making. Look at your solution where we proceed. The reason why I'm only spotting these mistakes is because I've solved this already before. So I already know what to expect. So we have 8 times 4 is, in this case, going to be 32. 32 times 6 is 2 carry 1, 18, 19. Yeah, 192. This looks more accurate. So that will be 1/192. I hope it's 192. I just finished getting now. 32 times 6, 12, 18, 19. Yeah, 192. So we have 1 minus 1/192 times sin 6x plus c. Good. So now we have our final answer to be 5/16x negative 15 over, no, not negative, minus 15/32 sin 2x plus 15/16 sin 4x minus 1/92 sin 6x plus c.